Hey guys, today we're going to be talking about introduction to exponent properties. And so trying something new today. We'll see how this works out. Not sure. It's some new technology, and you get to actually see my face, which is probably not a good thing for you. But at the same time, we can kind of use a whiteboard on here electronically, and maybe it'll work pretty good. I'm going to assume right off the bat that you don't know anything about exponent properties, so this is probably going to be a little bit of a long video, but it's okay because we need to go through this really well to make sure you have it, because everything we do in the rest of this chapter is really going to build on this. So I want to make sure that you get this. Okay, so I'm going to go ahead and move over to the whiteboard now, and I'm just going to start with a real basic example. Okay, so we're going to start with 2 squared. Okay, so the way we read that is 2 squared, and a couple of different parts here that we could talk about. Of course, right here, this part is your exponent. Okay, and I know that looks terrible. It looks like a second grader wrote it. But again, I'm trying to use this new pen, so it may take a little bit to get used to it. But the other part of this is actually here, and this is called your base. Okay, so when we read this, we read it 2 to the second power, but actually what we're really saying is this exponent just tells me how many different times I'm going to repeat this base. And the other thing you need to recognize is that there is multiplication between those. So what I mean by that is we could rewrite 2 squared as being 2 times 2. Okay, so all I did there is I just repeated the base twice, 2 times 2. And so 2 times 2 equals 4. So again, if we were to choose a different example, maybe we say 4 to the third power. Again, what we're saying here is this exponent tells me how many times I'm going to repeat this base, and then it's also going to tell me that I've got multiplication in between it. So I could rewrite that as 4 times 4 times 4, okay? So 4 times 4 is 16. 16 times 4 is 64. So 4 to the third power is the equivalent of 64. So it kind of gives you an idea of how the basic, what the exponent is and what it really is telling you that it's doing, okay? So now let's clear this out, and let's kind of start building some knowledge here. And we're also going to be talking about zero exponents and negative exponents, okay, and why they are what they are. So let's start again with our example we started with of 2 squared. Okay, we've already identified that 2 squared is the same thing as 2 times 2, and that in fact equals 4. Now let's move ahead and let's say 2 to the third power. Okay, so 2 to the third power would be the same thing as 2 times 2 times 2, which 2 times 2 is 4. 4 times 2 is 8. So you might start seeing a pattern. I'm not sure. Let's do one more. 2 to the fourth power. So what that means is 2 times 2 times 2 times 2. And so again, we kind of can see a pattern that I've already got 2 times 2 times 2 already figured out. That's 8 right here, right? So all I really need to do is multiply it times 2 again, and that gives me 16. Now what I want you to notice, what is happening here is that I'm really just multiplying by another 2 is all I'm doing when I move up this direction, right? So now let's move the other direction. Let's say 2 to the first power. What am I really saying? I'm saying I'm just going to repeat this base of 2 one time. So really, the answer there is just 2. So what happens when I do 2 to the 0 power? Question mark. I don't really know. I mean, when I multiply times 0, like 2 times 0, normally if I multiply by 0, the answer is just 0. So maybe it's 0. I don't know. So let's go to Desmos calculator real quick, and let's just try it. Let's see what happens. So if I put in 2, and this little button right here will let you raise to any power you want. So if I click that button and I go ahead and put 0, then it tells me that 2 to the 0 power, again, question mark, is 1. What? 1? Of course, I trust the Desmos calculator has been pretty faithful to me so far, so I'm going to go back here. I guess I'm going to change my answer and say Okay, Desmos said it was 1. Doesn't really make sense, but okay. So let's try some more. Let's say 2 to the negative 1. See, we started at 4 and we're kind of moving the other direction. So let's say 2 to the negative 1. What's going to happen there? Well, let's go back to Desmos again. And let's say 2 raised to the negative 1 power. And notice what it gives me for an answer right here. It gives me 0.5, which is the equivalent of 1/2, right? So it's the same thing as 1/2. Let's do one more. 2 to the negative 2. 2 to the negative 2. 2 raised to the negative 2 power gives me 0.25, which is the same equivalent of a quarter, right? A quarter of a dollar, if we think about it in money cents. So that's the same thing as 1/4. So we generally want to keep things in fractions, especially when we get to Algebra 2 and some higher level math. So here we go. This is what we have so far. I want you to notice what happened. When we went up, we were multiplying by 2. So how sensibly then, what's the opposite of multiplying? Well, the opposite of multiplying is dividing, right? So really when I go down this way, I'm really dividing by 2. 16 divided by 2 would give me 8. 8 divided by 2 would give me 4. And 4 divided by 2 would give me 2. Now it kind of helps me understand why in the world that 2 to the 0 is 1, because if I take 2 divided by 2, then guess what? I'm going to end up right back at 1. And if I take 1 and I divide it by 2, I'm going to end up with 1/2, okay? Then this last one, if I take 1/2 and divide it by 2, I'm also going to get 1/4, okay? What I want you to think about is I could also write this as 1/2 to the first power, right? Because 2 to the first power is in fact 2. Watch this. I could also write this one as 1/2 to the second power, because 2 to the second power is in fact 1/4. So what I want you to kind of recognize a pattern, okay? First of all, when I have anything to the 0 power, it actually is going to always equal 1. No matter if my number is 147 to the 0 power, and I know you probably don't believe me, so I'm going to go ahead and do it over here just so you see it. 147 raised to the 0 power still gives me an answer of 1. So no matter what the number is, or the letter, because we're going to be talking about variables too, no matter the letter or the number, I am still going to get an answer of 1 if I have it raised to 0. Now, the other thing we need to notice about negative exponents, okay? Notice what happened. The 2 to the negative 1, the 2 just went down to the bottom, okay? It just flipped, it just reversed. So instead of being on top, it was actually on the bottom, okay? So in other words, if I had 3 to the negative 2 power, the way I would write it is I would write a 1, and I'm going to take this 3 and move it to the bottom. The only difference is instead of negative 2 power, it's now going to become positive 2 power, okay? And if I were to try to finish that out, 1 over what is 3 squared? Well, 3 squared is the same thing as 3 times 3, which is 9. So my final answer for that would be 1/9. And again, we'll go over to Desmos real quick and just let you see that is in fact the case. 3 raised to the negative 2 power gives me that right there. If I were to change that to a fraction, it will not let me do that. But if I do 1 divided by 9, notice it gives me the same exact number, okay? So you can kind of see the pattern that's going on here, hopefully, from these notes, all right? So now let's look at some live examples. I think that's the best way to try to do this, and these are similar to what you're going to see on your practice, okay? So let's take a look at this real quick. I'll go ahead and clear this canvas out, and let's start with, we'll call it number 1. Number 1 is 3 to the 3rd power, okay? So what does 3 to the 3rd power mean? 3 to the 3rd power means 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 equals 27. So my final answer for that one would be 27. All right. Let's look at what we're going to call number 2. And we'll say that's 7 to the 0 power. Now again, what is any number to the 0 power? Well, we just discovered that any number to the 0 power is actually going to equal 1. Again, I know that maybe does not make sense, but it's because, again, every time you're dividing by whatever this base number is. Okay, so 7 to the 0 power equals 1. So let's talk about number 3. Number 3 is 2 to the negative 4 power. Okay, 2 to the negative 4 power. So the first thing I'm going to do is I'm going to place that underneath of 1. Okay, so I'm still going to keep the same base. The only difference is this exponent is no longer negative. It is positive. So I have 1 over 2 to the 4th power. Well, what is 2 to the 4th power? 2 to the 4th power would be the same thing as 2 times 2 times 2 times 2. So I'm going to end up with 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And again, you can type these into the calculator and get answers for those, okay? All right, so let's take a look at a few more examples. We'll call this one number 4 if you're taking notes. So number 4 is negative 4 to the 3rd power. Okay, there's something I really want you to notice about this. Okay, you do not see any parentheses whatsoever. Okay, so this negative is out here to the front. It's not really attached with this 4. As a matter of fact, we could think about this as being negative 1 times 4 to the 3rd. Okay, that would be an equivalent statement. So I want you to understand that that really does make a difference, okay? Because what I'm really doing is I'm taking 4 to the 3rd power, which is 4 times 4 times 4, okay? And I am multiplying that times a negative 1. So notice what happens here. I get 4 times 4 is 16. 16 times 4 is 64. But now I have 64 times a negative 1. I'm going to get a negative 64. You say, what's the big deal? I don't see what the difference is. Let's go back to Desmos real quick, and I'm actually going to clear out some of this other stuff out of the way. And let's go ahead and do exactly, let's write it exactly like I did when I wrote the problem. So negative 4 raised to the 3rd power. And notice what it gives me. It gives me negative 64. Now let's say, for example, I just decide on my own that, well, I think this needs some parentheses around it. So I'm going to say negative 4, and I'm going to raise that to the 3rd power. I want you to notice it's still negative 64. Well, what if this was a positive example? Okay, let's go back and let's take a look at this. So I want to look now, number 5. Let's say we had negative 2 raised to the 2nd power. Okay, and I'm going to do it 2 different ways, and that way you can kind of see what's going on. And this is really important because whenever you see parentheses in a problem, it's important. You need to put it in the calculator. I'm going to show you right now why that's the case. All right, so let's look at this. We have negative 2 squared gives me negative 4. Notice if I take that same negative 2 squared, but this time I'm putting it inside the parentheses. Notice what happens. I get totally different answers. For negative 2 squared with the negative to the outside and no parentheses, I get a negative 4. And for here, I get I'm squaring the whole negative 2, okay? Which kind of, again, makes sense if you think about it. What you're really doing here is you're taking negative 2 times negative 2. Well, negative 2, a negative times a negative is positive, so that becomes a positive 4. Here, again, I'm really taking negative 1 times 2 times 2, which gives me a negative 4. So it's really important that if it has parentheses, that you put those parentheses into the calculator so that you can kind of see what's really going on, okay? Now let's add some variables to this. You knew we had to do it because it's just the way we do it as math people. So let me go ahead and erase the screen again. And we're in the home stretch, so just hang with us here. So this is going to be number 6. And let's say 4x to the 0 power, y to the negative 2 power. Now, what I want you to notice about this particular problem is that there is multiplication all in between these. As a matter of fact, we could rewrite this as 4 times x to the 0 times y to the negative 2, okay? So there's multiplication all in between these. These are like their own little individual pieces, okay? So let's look at them as such. Let's look at them as individual pieces. So the 4, I'm not really doing anything with it. It's just kind of out there on its own. So the 4, I'm just going to rewrite. Now let's think about x to the 0 power. We said that 1 to the 0 power is still 1. We said that 2 to the 0 power is 1. We said 147 to the 0 power is still 1. So what do you think x to the 0 power is? Well, it's 1. So this just becomes 1, okay? So I've really got 4 times 1, which I don't even really have to write because it ain't really going to change anything, but we went ahead and wrote it anyway. And then notice what's happening here with this y. I've got y to the negative 2. What happens when I have a negative exponent? Well, I need to put it underneath of 1, right? So I'm going to do times 1 over y, and now all of a sudden this is going to become a positive exponent, right? So think about this. I could rewrite all of these as fractions, and when you multiply fractions, you just go straight across. So think about what really happens with our answer. I've got 4 times 1 times 1. Well, that just equals 4. And I've got 1 times 1 times y squared. Well, that just equals y squared. So ladies and gentlemen, I end up with this final answer for this problem. So notice what happened from our original. Here we had 4 that just stayed where it was. We had x to the 0 power, which kind of just goes away because it's really just becomes 1, and anything times 1 is just itself. And then this y, we ended up moving down to the bottom of the fraction because it was raised to the negative 2 power. So pretty simple, I think. Again, if it's negative, you have to move it underneath, okay? So now let's look at another example. Maybe it takes this up just a little bit further. I promise we just got 2 more to go. So number 7 is 3x to the negative 2 over 2y to the negative 3. So a couple things, again, I want to notate here is that there is multiplication between this 3 and this x to the negative 2. Okay, those are kind of like separate units. Now, if this had parentheses around it like that, then we would have a totally different problem, okay? That would mean that this whole quantity inside here is being raised to the negative 2. But we don't have that situation, okay? So I'm going to try to erase just that part. Also erase my negative, but I can put that back. Okay, so what we need to think about is what needs to stay and what needs to go, okay? So let's think about this for just a second. The 3, does it need to stay or does it need to go? Well, there's no negative that's being applied to it, so we can just leave it where it is, okay? Now, what we need to think about is I've got a fraction here. Where does this x to the negative 2 need to go? Well, it's a negative, so it needs to go to the bottom, right? So I'm going to go ahead and write x squared down at the bottom. So we've dealt with those 2 issues. I'm going to go ahead and kind of mark those out. Now, what about this 2? Does it need to stay or does it need to go? Well, actually, it needs to stay because this again, there's no parentheses, so this negative 3 is not being applied to it. The negative 3 only applies to this y, okay? So what I'm going to do is I'm going to go ahead and leave the 2 where it is. Well, what do I need to do with the y? Well, you say it's already on the bottom. I can't put it on the bottom if it's already on the bottom. Well, we need to just do the opposite, okay? Instead of taking it to the bottom, if it's already on the bottom, we need to take it to the top. So what I'm going to do here is I'm just going to write y to the 3rd right there because this is going to become positive. When I move it, it changes signs, okay? And so my final answer that I'm going to end up with is that guy right there, okay? Last problem, and you're saying to yourself, thank goodness. Well, again, I'm trying to just help you make sure that you've got all the tools you need to be able to do what you need to do on this practice. So here we go. We have x to the negative 4. We have y squared over 2 to the negative 3. So again, let's just take it one piece at a time. Remember that there is multiplication between everything, and then let's think about what needs to stay and what needs to go. So let's start with our x to the negative 4. Does it need to stay up top or does it need to move? Well, because it's a negative exponent, it actually needs to go to the bottom. So I'm going to go ahead and make me a fraction bar. And I'm going to go ahead and move x to the 4th down to the bottom. Now, what about my y squared? Does it need to stay or does it need to go? Well, y squared, it's positive, so I'm just going to go ahead and keep it where it is, y squared. Last but certainly not least, I've got 2 to the negative 3 that's on the bottom, okay? So because it is being raised to the negative power, I need to move that to the top. So I'm going to move it to the top, and all of a sudden it's going to be a positive exponent instead of a negative. And I just have one more last step to go, which is to go ahead and kind of clean this up because this can be simplified further. Remember, in mathematics, you want to try to simplify as far as you possibly can. So 2 to the 3rd power is going to be 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So it's going to be 8y squared over x to the 4th. And that is exactly what you need to do. And so hopefully this has been helpful to you. If you get into this and you have issues, please, please, please contact either me or Miss Wheeler, and we would be glad to help you with this because, again, this is the intro. Everything else that we do is going to build on what we're doing right now, okay? So if you don't understand it, we really need to make sure that you do understand it before all is said and done. So be sure to contact us if you need any help, okay? Thanks.